In this course section here, we're going to dive into authentication. We're going to see how we can authenticate users in our React apps and how we can add authentication to our React apps to begin with. And for that, we're of course going to learn how exactly authentication works in React apps. We'll then of course also implement user authentication and see how our front-end React app communicates with a backend that enforces authentication. And we'll dive into important topics like auth persistence, which simply means that we want to keep track of whether a user is logged in or not. And we're also going to explore how we can automatically log out users after a certain time span. Along the way, we're also going to explore one or two new routing concepts which fit really well into this section and into this project we're going to work on in this section. And by the end of the section, you will therefore know how you can add authentication to your React apps. Now, for this section, I have a demo project prepared, and that is actually the project we also used in the routing section with some extra features. Especially the backend which I'm providing for you, this dummy backend API, learned some new tricks and does now enforce user authentication and support user creation and login. And before we start writing some code here and before we dive into this project, it is of course important to understand how authentication actually works in React apps and what it actually means. Now let's start by clarifying what exactly authentication means. In the end, it means that certain resources, certain backend routes, for example, should be protected and should not be accessible by everyone. So the front-end application, the React application that wants to access certain backend resources must authenticate before this access is granted. It must get permission. And for that, of course, the question is, how does our client-side React application get permission from that backend application running on a server? Well, it all starts with sending a request with user credentials, so with an email and a password, for example, to that backend server. That backend server is then able to validate those credentials or create a new user if that's what we're doing. And then if the credentials are valid, if we did provide a valid email password combination, then the server will send us back a response that basically gives us permission to access certain protected resources. But how does this response look like? Is it a simple yes or no? Yes, you have access. No, you don't have access. Is that enough? Well, the answer is a yes alone would not be enough, because if a server responds with a yes, and in future requests from the client to the server, we then simply append that information that we got a yes in the past, that of course is not enough, because we could simply fake that. We could simply say that we have permission. So the server must reply with something else than a yes or no, something that can be validated on the server and that proves that we really got permission from the server in the past. So therefore, we can't just save and use a yes answer after logging in. We can't just attach a yes to future requests that want to access protected resources, because we could fake that. Now, there are two main solutions for that. We could use server-side sessions or authentication tokens. Now, server-side sessions are a very popular solution, especially for full-stack applications where you don't have a decoupled front-end and back-end, as we do often have it with React though. So it's not ideal for React, as you will learn. But the idea behind server-side sessions would be that on the server, after a user was logged in and authenticated, we store a unique identifier on that server. We basically store the yes on the server and map that to a specific client with help of an ID that's then sent back to the client. And the client then sends that ID with future requests which do try to access protected resources. And since we stored a yes mapped to that ID on the server is able to check whether that client really does have permission to access protected resources. Now, server-side sessions are a great way of solving authentication or of enabling authentication, but they do require a tight coupling between backend and frontend because the backend must store information about the client. And with React apps, you are often talking to decoupled backend APIs, which are not closely coupled to a client and which don't store any client-side information. And that's where authentication tokens come into play, and that is indeed the mechanism we will implement in this course section here. The idea behind authentication tokens is that on the server, after a user was authenticated, so after a user sent a valid pair of credentials, for example, we create but don't store a permission token, which is basically a string that is created according to some algorithm and that includes some information. So we create such a token on the backend and we send that token back to the client. Now, the special thing about that token is that its validity can only be checked and proven by the backend that created that token, because the token is created with help of some private key which is only known by the backend. So in future requests from the client to the backend, we attach that token to those requests, and the backend is able to take a look at that token, validate it, and see if it is a token that was created by that backend. And if it is a valid token, then permission to those protected resources is granted. And that is exactly what this dummy backend API, which I'm providing to you here, does. In this dummy backend API, when a user signs up or logs in, what I'm doing in the end is I'm creating such a JSON token, as it's called, a JSON web token. Now, that token is created with help of a third-party package, and it's a very simple piece of code that I'm executing here. Under the hood, I'm using that third-party package for creating a token that is created with help of a private key that's only known by the backend. Of course, in reality, you would have a safer key than that simple key, and you would probably not include it in your code base, but this is just a dummy backend which we're using as a demo. So here I'm creating such a token, and again, that token is in the end just some string created according to some algorithm and signed with that key. And in future requests from the frontend to the backend, I can run those requests through some extra middleware, as it's called, so through some extra check on my backend to validate whether those requests do include a valid token. I'm validating this with help of a middleware I wrote myself, which simply funnels the incoming request on the backend through a couple of checks where I in the end check whether a valid JSON token was attached. And when I validate that token, I am again taking that key into account. Now, you don't need to fully understand that backend code because this is not React and that's not the focus of this course. You do learn more about Node.js and Express in my Node.js course if you want to learn more about that. But you should understand that I'm creating and validating tokens here on the backend, and that some routes are protected by some extra middleware in front of them. Some extra middleware that checks whether the incoming request has a valid token attached, and if it doesn't, then an error response would be sent back. It's also worth noting that not all backend routes are protected. There are certain routes which don't require authentication. For example, if you want to get a list of all events, then for this API, that's possible without being logged in. But if you want to create a new event or if you want to update an event, then you must be authenticated. And as I mentioned before, this is the same application we already worked on in the routing course section, and therefore we are still dealing with those events you saw there. So that's the backend, and that's how this token-based authentication is implemented. And therefore, ultimately, if we go back to this picture, the server does not send back a yes or no response after we log in, but instead a response that includes this token, and then on the client side, in the React app, we have to store that token, attach it to future outgoing requests, and use that token as an indicator whether a user is logged in or not. because we might want to update the UI to, for example, show a log out button if we are logged in. And we can use that existence of that token, which we get back from the server, to find out whether the user is currently logged in or not. But we're going to implement all these things throughout this course section, of course. So let's now get started. And for that, we have this demo project as mentioned. And I do strongly recommend that you go through the routing section first so that you understand this project and you understand the code in that project. It's almost the same code as we had it at the end of the routing section. It's just a backend API that was enhanced with those authentication features. And I added a new auth form component and its styling here, which we'll use in this section, and a new authentication page, though I haven't added any route configuration to lead to that page yet. We're going to do that together instead. So once you have that project on your machine, once you downloaded it, you should navigate into this backend API folder and there run npm install to install all dependencies, and then npm start to start that server. Then in a separate terminal, because you must keep that backend server up and running in order to be able to communicate with it, in a separate terminal window, you navigate into your front-end application, and there you must also install all dependencies, and then you can start the development server with npm start there as well. And now we can start writing some code. You should then see a page that looks something like this, by the way. So now we can start writing some code, and as a first step, I want to make sure that we have a way of going to that authentication page. Maybe for a /auth route. And of course, feel free to implement this on your own as a small little practice. I'll take a short pause here to let you pause the video and implement this on your own, and then thereafter we'll do it together. So let's now implement this together. For this, of course, we go to app.js, where we have all these route definitions. And here I want to add a new route definition for this auth route. Now, the auth route should still be part of my root layout. I still want to have that navigation on top of it and so on. So therefore, it will be a sibling route to this home page and to this entire route stack of my events routes. We could add it here, maybe in front of the newsletter, though the exact position doesn't matter. The path will be auth. You could also add /auth, as this doesn't clash with the parent path, but a relative path will do. And then the element is the authentication page component, this JSX code here. And for that, you also must import the authentication page, of course. Now that's all you have to do. And with that, we should be able to visit localhost 3000/auth and see this authentication form. Of course, it would also be nice to have an entry here in the main navigation, and therefore I'll go to my main navigation component here. And in there, I'll simply copy that newsletter list item here and add a new nav link to /auth, which also should get this active class if it is active. So I'll keep that code. Give this a caption of authentication. And with that, of course, we do have this new entry here, and we can go to this page through our navigation. That's of course nothing new, but that is how we get started with adding authentication. Now we can reach this auth form. Now, as a next step, before we actually start adding authentication logic, I want to dive into an additional routing concept that allows us to improve the user experience in this application, and that fits really well into this course section here. So as mentioned, I want to dive into another routing concept we haven't learned about yet, which fits very well into this example, which is why I'm covering it here in this section. We get this button here on this auth form, which basically allows us to switch to the create new user mode. In the end, it's the same form, but what will change, at least later, is that in one case, if we click save, we do actually try to log in the user. We send a login request to the backend. On the other hand, if we are in create a new user mode, we send a request to the backend that wants to create a new user. So we're sending different requests based on which kind of form we loaded here. We could also enhance the form with an extra password confirmation input, for example, if we are creating a new user, but we'll not do that here, but I'd like to switch between these two modes. And as you can of course tell, we are able to switch between those two modes. But at the moment, this is implemented with help of useState and this logic here, where I basically toggle this isLogin state whenever I click this button down there. That of course works, there's nothing wrong with it, and you could keep it that way. However, we could also leverage a standard web concept for managing this. We could leverage query parameters, search parameters as they're also called. Now, a query parameter is in the end a parameter that's appended in the URL after a question mark. And we could say that we, for example, want to support a mode query parameter, which is either set to log in or to sign up. And depending on what it's set to, we want to load a different version of that form. So it's the same route, it's the same path. The path is always /auth, but we get this extra parameter which defines how exactly this component should be rendered. And that's not uncommon to do. And an advantage of using query parameters would be that we can directly link to this page in signup or login mode, so that we could link a user directly to the signup page, even though it's one and the same page, just with a different UI being rendered. And that's why I want to replace this state-based logic with my query parameter logic, not because it's generally better, but because it offers these advantages I mentioned. Now, to switch to that state-based logic, I will get rid of this switch-auth handler function and the useState call here, and we can get rid of the useState import. And instead now, I want to replace my button down there, which I use for toggling, with a link. So here I will use that link component from React Router DOM, and I'll then replace this button here with that link, get rid of that type attribute, and get rid of the onClick handler. And instead we set the to prop on that link. Now, where do we want to link to? Well, we want to stay on the auth page, so we could link to /auth, but that's redundant since we can also just set up a relative link that stays on the currently active route anyways. Therefore, I just want to add my query parameters here by adding this question mark and then the name of my parameter, which here is mode. Then I set this equal to, and then the value to which it should be set when we click this link. And that should be either log in or sign up, depending on whether we are currently on the login or sign up page. If we are on the login page, if we are in login mode to be precise, then I want to set this to sign up. If we are in sign up mode, I want to set it to login so that we can switch to the opposite mode. Therefore, this must be set dynamically here, and I will use the template literal notation to easily inject something here. But the something I want to inject is of course based on the currently selected mode. And I of course want to manage my mode here with query parameters, as I just mentioned. Therefore, I must get access to the currently set query parameters to know in which mode I am. I also need that information to correctly set the title and so on, by the way. Now, React Router gives us a hook that makes it easy to get access to the currently set query parameters. And the hook is called useSearchParams, because query parameters are officially called search parameters. We can call useSearchParams here, and this actually returns an array, and hence we can use array destructuring to get access to the elements in that array. And there are two elements in that array. The first element is an object that gives us access to the currently set query parameters. And the second value we get from that array is a function that allows us to update the currently set query parameters. Now, I don't need that function here because I will update the query parameter with help of that link that sets the query parameter, but I do need to get access to the currently active query parameters. Therefore, I will just get that first element from that array. And then here we can get the information whether we are in login mode or not by accessing this search params object here. And then there is a get method, which allows us to retrieve the value for a specific query parameter. And here it's the mode query parameter I want to retrieve the value for. And I want to check if the value is equal to login. So I'm in login mode if the mode query parameter is currently set to login. If it's set to any other value, then I assume that I'm in sign-up mode. So that's how I retrieve the currently set query parameter. Since I named it isLogin, that other code here also should continue to work, because previously my state was also named isLogin, so that code should still work. That's why I chose that name again. And now we can use that isLogin information here in our link to set the mode to a different value. If isLogin is true, so if we are in login mode, then the new mode should be set to sign up. Otherwise, if we are in sign up mode, we want to set it to login. So that's the code we add here. And with that, we'll have a link that allows us to switch between modes. And that's already all we have to do. If we now save this file here, this auth form component, we got this login link, and we can click this link to switch between our modes. And if you take a look at the URL here at the top, you will see that this URL does reflect that mode with help of that query parameter. And that is just an alternative to using state, but now we can directly link to that page in a certain mode. We can also update our main navigation now if we want to, and for example, link to that auth page with mode being set to login, so that if we click that authentication link in the navigation bar, we also load this auth form in login mode by default. Okay, so now we can switch with help of a routing feature here. That's nice. Now let's finally focus on authentication, and let's make sure that we can authenticate. And that all starts with enabling user creation. On this dummy backend API, which I'm providing to you, there is a route which allows us to create users. We got this sign up route here, where I in the end then validate the input, the email and the password, and I return an error response if invalid credentials were provided. If the password is too short, for example, it must have a min length of 6 characters here. And if everything is valid, then I create a user, store it in my file here, in this events.json file in the end. We could also use a database, but for this dummy backend, we're using this file. And I create such a token and send that token back to the frontend. That's what's happening here when we trigger that sign up route on the backend. To be precise, when we send a post request to that sign up route. Now on the front end, this of course means that if this auth form is submitted, we want to send such a request. Now that auth form here already uses the form component provided by React Router, because I want to use React Router's data fetching and submission features you learned about in the routing section for sending and getting data. And therefore we of course must add an action to our route here, an action that is triggered when this form is submitted. For that, I'll go to my authentication.js file, to this authentication page component file, and there I'll export an async function called action, as we did it multiple times in the routing section, and that action will be triggered whenever this auth form is submitted, because it is on the same route as this auth form is on. Now in this action here, we of course must get access to the form data that was submitted. And we do that with help of the request object that's part of that data package that we get as a parameter in this action function that is executed by React Router. Again, if this is all brand new to you, definitely go through the routing section first. I do explain how React Router and how this action feature works in detail there. So now here we got this request object, and we now of course want to get hold of the data that was submitted with the form. And we can do that by calling request.formData, this method, and we await this, and this gives us a data object, which we can then use to search for the email and the password that was entered. Therefore, we can construct an auth data object where the email is retrieved with help of data get email. This get method exists on this data object that is returned by form data. So this gives us the email address that was entered by the user. And the password can be retrieved with data get password like this. So that's how we get this data. Now, of course, we want to send different requests based on the mode this form is in, if we are in login or sign up mode. So therefore, we also must take a look at this query parameter in our action to find out whether a sign up or login request should be sent. Now, thankfully, it's also quite straightforward to get hold of that, even though we can't use the use search params hook here. That won't work because we're not in a component here. But we can use the built-in URL constructor, which is provided by the browser, and pass our request.url to it to then access the search params object on that URL object that's instantiated here. So that's how we can get hold of our search params here on the backend with some default browser features. And then on that search params object, we can also call get and extract the mode here. We can also say that if it's undefined, we maybe want to use sign up as a default or login, whatever you want. Here I'll go for login. And therefore here I then have the mode, which is either equal to login or sign up, or in general, whichever value mode is set to. So now we know which mode we are in, and we can get the data. Therefore now we have everything we need to send a request to that backend. And I'll do this with my fetch function again, with the browser's default fetch function. The URL is localhost 8080, and then we want to send the request to either /signup or /login based on which mode we are in, because /signup and /login are the two routes supported by the dummy backend. Now, conveniently, mode is login or sign up, so we can simply append the mode here after this URL. Now, of course, users might deliberately enter some unsupported mode here, like ABC, and to defend against that, we can simply check if mode is not equal to login and mode is not equal to sign up, for example. And if that's the case, we could throw a new error here. We could throw a new error response, to be precise, and import the JSON function from React Router DOM, as explained in the routing section, and then throw an error response here where we, for example, say unsupported mode, and where we set the status to 422 for invalid user input. This is one way of handling this. Alternatively, we could simply set the mode to sign up if it's an unknown value. That is totally up to you. Here I will just throw this error. Okay, so that's one thing. Now we're sending this request to this URL, which incorporates that mode, and that will give us back a response, which we want to await, but that's not everything we have to do. Instead, we need to configure this request and, for example, set the method to post, because on the backend, both sign up and login expect to get post requests. We also want to set the headers and add the content type header here, which should be set to application JSON, so that on the backend, the sent data is extracted correctly. And speaking of that data, that should also be added with that body field here, where we have to convert it to JSON format with JSON stringify, and where I simply convert my auth data. So this data up here is used down there. That's how that works. With that, we're creating that request and we're then storing that response in a constant. As a next step, we can then add the code to handle that response. For example, we could check if the response status code is equal to 422, which means we have some validation errors, or if it's equal to 401, which will also be sent back from the backend in certain situations. For example, if we try to log in with invalid credentials. And in those cases, if we get these error codes from the backend, I want to return some data to my route component, to the auth form in the end, so that I can show an error message there and show the validation errors next to the form, for example. Therefore here I will return my response. And as you learned before, you can return responses like this. React Router will automatically extract the data for you. Now if I make it past this check, I also want to check if the response is maybe not okay, if we have any other error, in which case I want to throw an error response so that my closest error element is rendered on the screen. And here I will then include an object where I add a message of could not authenticate user, something like this. And I'll add a status code of 500 here. Now, if we make it past all these steps here, the user creation or sign up did succeed. So soon we will have to manage that token here, which we get back from the backend. But for the moment, we'll not do that yet, and instead just redirect the user. So therefore, I'll return a response where I redirect by using that redirect helper method from React Router DOM, and I call redirect here to redirect a user to the starting page, for example. So once we are logged in, we're redirected to the starting page. That's what I'll do here. So that is the action that should be executed whenever this auth form is submitted. And with the backend server up and running, this should all work without any further changes. The last thing we have to do though, which is easy to forget, is that we add this action to our route definition. We must register it there, otherwise it won't be picked up by React Router. So here I'm importing this action as my auth action, and this auth action is now set up as an action here on this route. So here we add the action key and point at our auth action function, which is exported by the authentication page file. And now with that, we got everything set up. If we are now in create a new user mode, we are able to enter some credentials here, like test@test.com. And then here any password of your choice, which should be longer than 6 characters. At the moment, we're not outputting validation errors yet. We'll soon do that. For the moment, just make sure you enter a correct password and a correct email, and click Save. And nothing happens here. But that's because I have an error here in my action. When I add headers, this must be headers. That's important, otherwise this isn't added as a header, and therefore on the backend the data isn't extracted correctly. So this must be headers. A small typo from my side. With that adjusted, if we hit save, we are redirected. And we are redirected because we did create that user. Now we can tell that the authentication succeeded by going back to authentication and switching back to create user mode. And if we now try to create a user with the same email as before, the password does not matter, but if it's the same email as before, you will see if I click save, nothing happens. The reason for that is that behind the scenes, we're actually getting authentication errors because the backend checks if a user with that email exists already. And if that's the case, it sends back an authentication error with status code 422. And therefore now we just want to handle this on the front end to show an appropriate error message, because it's all working as it should, but we're not giving the user the feedback he or she should be getting. So let's now make sure that we're showing validation errors or any authentication related errors we might be getting in general here above that form. And that is, of course, something we already did learn about in the routing section. For that, I'll go to the auth form.js file. And in that file, I simply want to get my action data. So the data returned by that action function that was submitted by that form. We can get that data with help of the use action data hook, as you learned. So here we can get that data with use action data. And we only get that data if our action returns something. If it returns something else than a redirect. So in this case, if it returns here, if we got a status code of 422 or 401. In that case, it will return a response to us that includes some information about the problem that occurred when trying to authenticate the user. So here, to output that information to the user, I'll output it below this h1 element and check if the data is generally set, if it's available, if we do have data, because we won't always have data, only if we did submit the form in the past. Then I check if an errors object is present on that data. It will be present if we have validation errors. And if that's the case, then I'll output an unordered list where I simply loop through all the error information I have. Now, since errors will be an object, I will use a built-in function provided by JavaScript, object values, to go through all the values in this errors object. So I'll pass data.errors to values, and that will give me an array of all the error messages that I have. So I'll then map my error messages to list items where the key is set equal to the error message and where I output the error message like this. I will also add another check down there and check if my data has a message, if I have the message property on this data object, and if the data object exists as mentioned. And in that case, I'll also output data.message here. So with that, I'm outputting any error data I'm getting. And we can already see that this was updated here and that this is the information I got when I tried to create a user with an existing email address. If I use a brand new different email address, then I of course won't get that error and instead I will succeed. Now the last thing which I want to add to this form here is a little indicator that the form was submitted and that we're waiting for the response. So I want to find out if we're currently submitting data. And we also learned about that in the routing section. We can use another hook for that, the use navigation hook, which gives us a navigation object. And that navigation object has a state property which holds the current submission state, so to say, or which lets us know whether we're currently submitting. So here I'll then add a helper constant called isSubmitting, where I check if navigation.state is equal to submitting. In that case, I know that we're currently submitting data, and I want to use that information down there at the bottom for this save button. Here, I want to disable that button if we are submitting, and I want to output a different text based on whether we are submitting or not. If we are submitting, I want to output submitting ... Otherwise, I'll output save. So that's how I updated this button. Well, and with that, if I go back and create yet another user with a different email address, I can click save, the button changes, and then I'm redirected. So now we get that sign up process down, and that's all working as it should. Let's therefore now focus on logging the user in as a next step. Now, when it comes to logging in, that actually all already works, because the action that we created here for this authentication page does send a request based on the mode we selected. It appends all the data that's needed, and the login route therefore is triggered correctly, the backend login route, I mean. Therefore, we should already be able to enter our valid credentials here, so the email and password which we used before for creating a user, and submit this. And indeed, it works. We're redirected and we are logged in. Now, if we use an invalid password, then we get an error here. Or if I use an email address that doesn't exist. But I can log in with valid credentials, and therefore we already got that login feature implemented. And therefore now, as a next step, we can finally focus on that token which we're getting back from the backend and which we must attach to requests to protected resources. Because at the moment you'll notice that if I, for example, try to delete an event here, the app crashes here due to an error. And it crashes here because we're not authorized to delete an event yet, because we haven't added that token to that outgoing request. That's therefore what I want to do as a next step, though before I do that, I will actually make sure that we do show an error page here if things go wrong. Now we do have an error page here in theory, but that's not showing up because on my error page, I am including that main navigation, which uses a feature that can't be used there like that. If I remove that, we do see that error page again. So we must attach that token to the outgoing request. Now, if the goal is to attach the token to outgoing requests, then of course, as a first step, we have to store that token when we get it back from the backend after signing up or logging in. Because just to bring that back in memory, on the backend for the sign up and the login routes, which I have here, even though you don't have to fully understand that code, I am eventually creating a token and I'm returning that token under a token key as part of the response that's sent back to the frontend. So on the front end, when we get that response, we now want to extract and store that token so that as a next step, we can attach it to outgoing requests. Therefore, here in my authentication file, in that action that is triggered when we submit the form, before we redirect the user away, we want to extract that token from the response. So here I'll get my response data by awaiting response.json. And that response data contains the token under a token key, as you just saw in the backend code. And that token must now be stored so that we can use it. The question is, where do we store it? And there are various options. We could try to store it in memory somehow. We could store it in a cookie. But a very simple and straightforward option is to store it in local storage, which is a browser API which we can use here, because you must not forget that this code and this action function runs in the browser. So we can use all standard browser features here. Therefore, here we can access local storage and set a new item here to store that token in that browser storage, so some storage that's managed by the browser. And I'll give it a key of token and then store my extracted token here. That's what I'll do. With that, for the moment, that's all I want to do. Now the token is stored here, and now we can get it from local storage when we need it for outgoing requests. Now, for that, I'll add a little helper function in a new folder called util, which I create next to my components folder, where I'll create a file called auth.js. And in that file, I'll add a function which is exported, which is called getAuthToken. In here, I'll get my token from local storage with help of the getItem function by using that token key. And then I'll return that token. It might look like overkill to create that function for that simple code here, but we'll add more code to that function later. That's why I'm creating it here. So now we have a function for extracting the token. We could have also added a function for writing and storing that token if we wanted to, but here I'm fine with that extraction function. And I now want to use that function in the places where I now do need a token. For example, in the event detail.js file. There we got this action where I do send that delete request in the end. Here I'm trying to delete my event. And we must add the token to this outgoing request. Now for that we must add headers, and we must add the special authorization header and set that to a value of bearer, white space, and then the token. That's simply the format the backend is looking for. That's the header and the header format the backend expects, so that is something we must add like this. Here I then want to add my token, but for that I of course must get my token as a first step. Now, thankfully, that is of course quite straightforward to do. We can use this new getAuthToken function which I just added and import it from that util folder. And with it imported, we can call it in this action to get our token, store it in a token constant, and add that token here for this authorization header. And with that, we're storing the token when we're logging in, and we're then using the token for attaching it to this delete request in this case. So with that added, what we can do now is again log in to make sure that we get a token and store it. You can now, by the way, also see that token if you go to the application part in your DevTools. There you can inspect local storage and you should see that your token is stored here. You could also delete it here if you wanted to clear it, but I'll keep it around. And now if I go to events and I select an event, I can click delete and confirm this, and I successfully deleted that event. I got no errors here because we did now add that token to the outgoing request, and therefore the event is gone. So that's how we can use that token. And of course, we don't just want to use it here for deleting, but also for a couple of other requests. For example, for editing. If we edit an event, then we also want to add the token. And the same is the case for adding a new event. This action is defined here in the event form.js file. And therefore here, I of course also want to add my authorization header, which is set equal to bara whitespace and then the token. And I want to get my token here as well with that getAuth token helper function, which must be imported just as before. So don't forget to add that import. And with it being imported, we can call it, we can get the token and attach it to the outgoing request like that. With that, we should be able to also edit and add events. And with that, we added the token to all routes that are protected on the backend, because here I am protecting my creation, my editing, and my delete routes. So therefore now, to quickly verify this, if I try to add a new event here without a real image, but this doesn't matter, I can click save, it is here. I can also edit this, hopefully. Yes, I can. And I can delete this. That's all working as it should. Now, getting that token, storing it, and attaching it to outgoing requests is an important part, but we can now also go back to our front-end application itself. We might want to update the user interface based on the current authentication status. If we have a token, for example, we might not want to show this authentication navigation item because it makes no sense to show that if we are logged in already. On the other hand, it makes no sense to show the edit and delete buttons or this new event button if we are not logged in, because allowing users to go there if we're not logged in makes also no sense. So updating the UI based on the existence of a token makes a lot of sense. However, that also means that we need a way of getting rid of a token. And at the moment, we would have to do that manually through the DevTools, which is of course not the solution we want to offer to our users. Instead, we want to add a logout route. And that means that in main navigation.js, in our navigation component, we want to add a new list item to our navigation bar that in the end shows a logout button. Like this. Now, this button should then trigger an action or whatever that deletes the token. And there are different ways of handling this. We could simply add an onClick listener and trigger a function that reaches out to local storage and deletes the token. But here I'll use the more official React routing embracing approach, and I'll add a new route. I'll add a new file in my pages folder called logout.js, and the special thing about this file is that it actually won't contain any component because there is no logout page. Instead, I'll just export a function, an action to be precise, which will clear my local storage, which will get rid of the token. So all I want to do in this action is I want to reach out to my local storage and remove my token with the remove item method. And then I want to return redirect with that redirect function from React Router DOM and redirect the user to the starting page, let's say, if a user logs out. So this might look strange, but it is simply a JavaScript file which holds an action. And now I can register a new route that only has that action and no component. And we learned about such routes before in the routing section already, so that shouldn't be too surprising or new. I'll add a new route here where the path is simply logout and where the action is that logout action I just created. Therefore, I'll import that action here and import action as logout action from /pages logout. And this logout action is now connected to this newly added route. Now we can send a request to this route here. We can submit a form that targets this route. And that's exactly what I'll do in my main navigation now. I'll wrap my button here with this form that's provided by React Router DOM. So I import form here. And then I'll add an action of /logout and a method of post, though that doesn't matter here, and save this. With that, we have this logout button, which we can click, and we're redirected. So that works as it should. Also got no errors here. And if we take a look at our application tab here now, we see that the token was removed from local storage. So that's how we can log out. And now with that, we can finally also make sure that we update the UI accordingly and check whether we have a token or not, to then, for example, show the logout button only if we are logged in and show the authentication item here only if we're not logged in, for example. So now to update the UI based on the existence of the token, I want to make that token easily available in my entire application on all my routes basically. And I also want to make sure that the information, whether the token exists or not, is automatically updated so that if the token would be removed because we log out, the UI automatically updates. Therefore, for that reason, I don't just want to call getAuth token, my helper function, here in main navigation, for example, to get the token, because that function is only called when this component is reevaluated, but it will not lead to the component being reevaluated if the token is deleted in the future. So I want a more reactive solution. And we could use React Context for managing that token across the entire application. That would be a perfectly fine way of doing that. But since we're using React Router, we can also again leverage that tool, that package for doing that. And we could, for example, go to our root route, which in the end wraps all other routes, as you can see. And there we could add a loader, which simply takes a look at local storage and extracts the token from local storage. And that token would then be available through the loader data of that root route in all other routes. The best thing about that is that React Router will automatically reevaluate that if we, for example, log out, if we submit that logout form. So it will then refetch that token and, for example, determine that the token doesn't exist and then update all the pages that use that loader data from that root route. So that is a very reactive solution, and that's therefore why I will use that approach. So here we can add our loader function, and I will put that in a separate file, in my Auth utility file actually. Here I'll add my token loader, and in that function here, I will simply call getAuth token and return the result of calling that. So that is quite straightforward. I will just use that helper function here. But now back in app.js, I will import this loader as the token loader from util auth and use that here on that root route. So now this will be called whenever a new navigation action occurs, for example, because we triggered a logout, and therefore we will check the current status of the token whenever the user does anything on the page, whenever the user submits a form or navigates around. And that therefore ensures that we always have the latest information about that token. Now here I have an error because I named this token loader already, so I should import it as token loader. And now with that, that should be working. So now we can use that loader data from that root route in all our other routes. In order to use data from that loader and easily get access to it, I'll assign an ID to that route. Root sounds like a fitting ID. And now in main navigation.js, we can use this use route loader data hook, about which we learned in the routing section already, to get our token here by targeting the root route. And we know that what we'll get here is the token because that is what that root routes loader does return. The token loader here does return the token. So therefore in main navigation, we now get hold of that token, and we now know that if that token exists, we're logged in, and if it does not exist, if this is undefined, we're not logged in. Therefore, we can conditionally show that authentication link here by checking if token exists and only rendering this list item if it does exist. Though that would show it if we are logged in, and we want the opposite, hence I'll add an exclamation mark here. Now that authentication link is only shown if we're not logged in, if we don't have a token. On the other hand, that logout button should only be shown if we are logged in, so here I'll have the opposite logic. I'll check if we have a token, and then I'll render this list item. With that, if I save this, you see I see authentication here, because at the moment I have no token. But if I do log in again, if I do submit that form with valid credentials, that changes and I now see logout instead. And we can use the same approach here for conditionally showing these edit and delete buttons or this new event button. For that, we can, for example, go to Events Navigation, which is where I have this new event button, and use the exact same approach as before. Use the route loader data hook, which is imported from React router DOM, to get our token by getting the loader data from the root route. And then we only show this new event link here if we have a token and not otherwise. Because if we're not logged in, it makes no sense to show this. And the same is true for the event item. There, I also will use the use route loader data hook to get data from my root route, and that data is the token. And that information can now be used to conditionally show that menu. Here, I only want to show it if we have a token, because otherwise we can't edit or delete this anyways. So with that, if we save this, I see all these items because I am logged in. But if I log out and I then go back to events, you see the new event button is gone and also edit and delete are gone. So that works as it should. Now it's good that we're conditionally updating the UI based on the existence of the token. What we can still do though is we can manually go to events/new, for example. So we can still reach that form even though we're not supposed to. Of course, submitting the form would fail because we actually wouldn't be able to attach a token to the outgoing request. So we still have that protection, but it would be even better if we wouldn't be able to reach that form at all if we're not logged in. So what we need is some route protection. Certain routes here should not always be accessible. To be precise, it's the edit route here and this new route here, which should not always be accessible, because we shouldn't be able to reach these routes if we're not logged in, because we won't be able to use them correctly anyways. So how can we add this kind of protection then? Well, we could utilize a loader. A loader that simply checks if we have a token, and if we don't have a token, redirects us away. And I'll add such a loader in this auth.js helper file. I'll add the check auth loader here. And in there, I'll simply call getAuthToken to see if I have a token. And if we don't have a token, then I will return and call redirect from React router DOM to generate a redirect response and redirect away to /auth, for example, so that a user is able to log in. Alternatively, we could also throw an error and show the error page. That is totally up to you. So now this loader here can be used to protect a route. That's one way of protecting a route. Now back in app.js, we can add that loader to all the routes that need protection. And that would be the check auth loader, which therefore of course also must be imported from that util auth file. And that check auth loader is added to the edit route here and to the new event page route. If we now save all files and I try to visit /events/new whilst not being logged in, you see I'm redirected to /auth. Of course, if I do log in here and I visit the new event route, I can go there. Also, if I enter it manually. That all works, but now we got proper protection in place to make sure that we can't accidentally visit pages we're not supposed to visit. Now we're almost done with adding authentication. I mean, it does work as it should after all, but one last piece is missing here. At the moment, we always stay logged in if we got that token once. So as soon as we got the token, we save it, and from that point on, we stay logged in. Now, that's nice, but unrealistic. Indeed, the backend creates a token that will actually expire after 1 hour. Now, that could be configured differently, but for security reasons, it's a relatively short-lived token. Now, you could definitely create more advanced authentication flows and setups, but here it is quite simple, and this token expires after 1 hour. Therefore, I also want to log the user out after 1 hour because the token is invalid thereafter. And I don't just want to log the user out, I also want to clear the token and I want to remove it from local storage. So after that 1 hour, the token should be removed from local storage and the UI should update accordingly. Now, to enforce that, we again got various options, and you can get creative here. One option would be to go to the root layout, so to this root.js file, and in that file, we could use the good old useEffect hook, which is not a React navigation feature, but which we can of course still use here. And then here, this useEffect hook could be used to set a timer whenever the root layout is rendered, which happens when the application starts, because that is the very first component we definitely load for all our routes. If you have a different setup where you have multiple sibling root layouts, this approach would not work, but here this is the one root component which definitely includes all other root components. So therefore we can go to this root layout and then set up our effect function here. And my idea behind this effect function is that I want to get my token here. And since I'm in the root layout and I'm getting the token here with help of the token loader, I can simply use loader data here. I don't even need to use route loader data and use the ID of the route, because here I already am in that very component that's rendered for the root route. And then here I got that token. And that token can now be set as a dependency for a useEffect, so that this effect function runs whenever the token changes. And here I simply want to check if we maybe don't have a token. If that's the case, I just want to return, because there's nothing to do then. If we don't have a token anymore, if this effect function was executed because the token was removed, for example, then we don't have anything to do. But if we do have a token, I want to set a timer. I want to set a timer that expires after 1 hour and that then triggers that logout action, so that basically sends a request to that logout route we added earlier. For that, we can use another hook provided by React Router. That's the useSubmit hook, which gives us a submit function. And we learned about this hook in the routing section, of course, which we can use to programmatically submit a form. And here I want to basically submit that logout form, which I have in my main navigation file. I want to send that logout request. That's what I want to do. We can do this with help of this submit function, which we also set as a dependency here on this effect function, because we're going to use it in the effect. And once that timer expired, I will call submit. I won't pass any data because there is no data to submit, but I will target this /logout action, this logout route, the action that belongs to that route, set the method to post, and that will therefore trigger that logout route and, well, start that logout process where we clear the token. Now here, I will set the timeout to 1 hour by multiplying 1 with 60, so 60 minutes, then 60 seconds, and then 1000 milliseconds, because set timeout expects to get the duration in milliseconds here. So that's 1 hour in milliseconds, what I'm calculating here. And with that, we get this effect function, which executes whenever the root layout component is rendered or when the token or the submit function changes. The submit function won't change though, but the token might change. And if we have a token, then we start that timer, which clears the token after 1 hour. That's what we're doing here. We can, by the way, also remove that use navigation import here, which we don't need anymore. So now we would clear the token after 1 hour. But this solution still isn't perfect yet. It still has a flaw. Now, which flaw does this solution have? Well, at the moment, we always expire the token after 1 hour. The problem is that we, of course, might have logged in, then we were away for 10 minutes, then we reloaded this application, and then, therefore, this effect was triggered again. We found a token in the local storage because we did log in 10 minutes ago, but now we reset that timer to 1 hour. That's not realistic because the token is already 10 minutes old, so it will actually expire in 50 minutes and the backend won't accept it anymore thereafter, but our timer is set to 1 hour. Therefore, it's not enough to always set this to 1 hour. Instead, we need to manage and register the actual token expiration. And to do that, we should go to our action that's triggered when we authenticate, where we do store that token. And here we should also store the expiration time, because that's the code that executes when we first get a token. Therefore, here we know for sure that the token will expire in 1 hour. Therefore, we should calculate an expiration date by creating a new date object. And then we can call the setHours method on that object. And that's a built-in object and a built-in method provided by JavaScript itself, by the browser to be precise. And then here we pass expiration getHours plus 1. So this basically creates a date that is 1 hour in the future. And then we want to store that date in local storage as well. We can name it expiration. That's the key in local storage, and the value is expiration to ISO string to convert this date to a standardized string. So now we're also storing the expiration date in local storage. And this ensures that we do respect that expiration date. Now we can update this getAuthToken utility function to also take a look at that expiration date and find out if the token did maybe expire. For that, I'll actually add a new function here, which I'll name getTokenDuration. And here I want to get back the remaining lifetime of the token in milliseconds. And I'll get that information by getting my expiration date, by accessing local storage getItem expiration, so by using that key we just used for storing the expiration date. And actually that's my stored expiration date, which I now must transform to a date object by simply passing that stored expiration date, which is a string, to the date constructor. And then I also need to get the current date, so the current timestamp, so to say. And the difference between the two dates, of course, is the remaining duration. So the duration in milliseconds can now be calculated by using that expiration date and calling getTime on it, which gives me the time value in milliseconds, and deducting now.getTime from it. So I deduct the current timestamp from the expiration timestamp. If the expiration is still in the future, so if the token is still valid, therefore, then this will be a positive value. If now is later than the token expiration, so if the token did expire, this will be a negative value. And here I simply return the duration. But I can now use that duration from getTokenDuration here in getAuthToken by calling getTokenDuration here, to check if token duration is smaller than 0, which means the token expired because we have no remaining time. It already expired. In that case, I will actually return a string expired here, so this special string, which I can then use in other parts of my application to trigger this logout action. For example, if I now go back to the root layout, here, I'm checking if I don't have a token. Well, I actually also want to check if token is equal to expired. So to this special string I'm returning here, if the token did expire, in which case I also want to trigger this logout action. And thereafter we can return because we don't need to set any timer thereafter. If we make it past this check, we know that we have a valid token, but now I nonetheless want to set a duration here that takes the remaining lifetime of the token into account. So here I will get the token duration by calling getTokenDuration, so that helper function we just added in the util auth file. And I'll also console log it here so that we can see if everything looks good whilst developing this. But I'll then replace this timeout time here with that token duration. That's now the updated useEffect code. With those changes made, I just also must make sure that in getAuthToken, I not always return expired, but I also check if we have a token at all. If we don't even find a token, then I want to just return. So I return undefined in the end. I don't even need to check the duration. If I don't do that, the UI would not be updated correctly because I would basically always return expired. But now with that, I'm not returning anything if we have no token, but if we do have a token, I'm also checking the expiration. So with that here, I currently have no token, but I'll now open my DevTools and log in here with my valid credentials, like this. And you now see that here, that is the token expiration. If I reload this page, this is already a smaller amount. Now, as I navigate around, it's not being logged because the root layout isn't re-rendered and the effect isn't running again. But eventually, this is ticking down and will lead to us being logged out after some time. Now, with that implemented, the last thing I want to do is here in my logout action, I also want to remove the expiration key from local storage because that's now also not needed anymore and should be cleared. And with that, we added authentication to this application. We are able to create users and log in, and our user interface reflects that. We're then able to work with the different features of this application, and for example, also delete events if logged in, because that token is attached to outgoing requests. We have that auto logout timer behind the scenes. We can log out manually, and we update the UI to reflect the current authentication status. In addition, we protect certain routes so that we can't reach routes we're not supposed to reach.